And now for the third and final bug eye set, at least for now. I think I misspoke at the end of the last video when I said that this chassis was different from the previous two. That's not true. It's actually the same as the second one, 16Z25, which is used in several models. So this should be identical to the second set that I restored. That's the one where I had the entire cabinet. This one's a little bit different though, because the owner of the set started doing some work on it before he handed it off to me, and he's already clipped out two capacitors. They were here as part of the power supply circuit, so I'm going to have to do some work there. So I just noticed something else. There's two fusible resistors in here. I noticed in all three sets they had some issues down here where these fusible resistors had been replaced in some manner. So we've got one here, and you can see the lead was clipped and a new one was twisted in place. There's another one over here. They're both 7.5 ohms. So, no, sorry, this one's 4.7 ohms and this is 7.5. No reason to have two. So I don't know what that's all about. I'll be taking the selenium rectifiers out and I'll clean up this whole area. I'll also have to do some detective work because when he took out the can cap up here, the multi-section one, he untwisted the wires and now they're just hanging here. I don't know what these wires are supposed to go to, so I'll have to trace those out. I do have the picture tube and I tested it. It's good. Now as for the controls, well, I can keep my fingers crossed that they're good, but I know there's already a problem with at least one of them. There's the brightness control. The shaft's completely gone. So I don't know what happened to that guy. It's broken off way down inside there. So there's no way I could attempt to turn it even if it is still good. Now these two are supposed to be short. They are meant to be adjusted by with a screwdriver, so that's okay. That's the vertical linearity and height. It's a vertical hold and horizontal hold. I did find one place that sells this type of control. And by this type, I mean instead of having a threaded collar around the shaft with a nut that you tighten down, this has two little metal tabs that protrude through the chassis, and then you twist them in place, and then a little plastic shaft. I need those for these sets because they need to be very, very short and then knurled for the knobs to push on. If you use too long of a control, it won't fit back inside the cabinet. I did find one place that has them, Antique Electronics Supply, but they only have them in 250K and 500K. But 250K is the value I need for the brightness. So I've already ordered up a few of them, and they're only 50 cents each, so there's a bonus there too. So in the first set I restored, it had a bunch of bad controls. The brightness on that one was arcing and this doesn't really work right. It goes from full brightness to no brightness. So I'll be able to replace that one, and I'll also replace this guy. Vertical hold should be 750K. The best I could find was 500. I figured I could take a 500K and put a 250K in series, or maybe put 125K on either end of it. I can hopefully get a usable range with that control. For the others, I'll replace them with whatever I can find on hand for now. Alright, now as for the rest of the set, it looks like it just needs the usual recapping job. So I'll do the same thing as the other two sets. Heat up the solder cups, pluck the old caps out, and pop new ones in. I just finished with the recap, which also included replacing a few resistors that were out of spec, and a few oddities. For example, inside of this tubing here is a 10K resistor. What I found in there, you may have noticed in the video, was it was a 10K resistor, and in parallel with that was a 47K resistor, which lowered the overall resistance to something around 8K or so. Well, I replaced all that with just a brand new 10K resistor, going off the schematic. Also notice that this 470 ohm resistor here was charred beyond recognition. And that is used in the audio output. It's this guy right here. So, curious to see if we get sound. And finally, this ceramic disc cap over here, there was a wire wrapped around both leads. One side goes to ground and one goes to this point, and this point was grounded out. That's used in the tuner or the IF, I believe. So that could also be another potential problem point. Alright, well, other than that, everything else went smoothly, and I didn't notice anything odd. I got the power supply rebuilt as well. Down there. So I'm going to flip this chassis around, and for the first power-up, I am just going to substitute a power resistor for the CRT filament. So just check the power supply works right and maybe get some sound. Then I'll dig out the picture tube and reinstall it. Alright, let's see. I've hooked up a speaker. I disconnected the plate cap on the horizontal output tube, so I don't have any CRT hooked up, so we shouldn't worry about any high voltage coming out of this. Got it plugged into an isolation transformer and variac tuned for about 120 volts AC. And I've got my multimeter on the B+ supply. I've already checked for continuity through the power cord and all the tube filaments, and that looks good. So here we go. It's a good sign. I got 300 volts DC, and the tubes are lighting up. B+ dropping down as the tubes warm up, and we've got static. We had static. And grab a knob for the tuner. Tuning. Busted. Noticed that earlier. This knob had a pretty bad crack in it, and it just finally gave out completely. I tried gluing that back together. Meantime, I'll grab one from another set. And nothing's happening as I change the channels. Alright, so now the troubleshooting begins. I just noticed something with this set on channel 6, which is low power local broadcast. When I turn it on, we briefly get sound, and it disappears as the set warms up. Just like that static we heard a moment ago. And there it goes. I'm going to try adjusting the AGC control on the back. It's not having any effect. fine tuning. Alright, that's a good sign, because that means probably the tuner and the IF, a signal is getting through partially at least. I have not tested all these tubes, although I did put all new tubes in the IF strip. But I do have a working set with the identical chassis, and I can just swap out tubes from that set, which I know works fine. The first thing I did was check the AGC control, which had been mounted here with an ohm meter, and the readings were just nonsense. They were jumping between infinity and 0 ohms. So I disconnected it, unmounted it, popped it open, and what do you know, it has that same problem as other controls in the other bug eyes I've worked on, where the carbon is falling off. So it's got to be replaced. It's supposed to be a 350K pot. I dug up a 100K and a 1 meg. I'll go with the 1 meg for now. I do have some 250 and 500K pots on the way, so I think I'll probably end up putting a 500K in there, but for now, should be good enough. It only uses 2 legs, so in other words, it wipes between 350 and 0. So having a higher resistance is no big deal. I'll just be using like 1/3 of the range. Here it is on the schematic. Alright, let's see if that makes any difference. Oh, and I also tested what remains of the brightness control, and not surprisingly, that is also shot, which is here, so I'll have to replace that guy as well. But even with that being open, wouldn't affect the sound. So, let's see if that control helped any. And there it goes. So, no it did not. I can try adjusting it. Alright, well the old one was definitely bad, so it would have had to have been replaced eventually anyways. But still got problems. So the next thing I'm going to do is go through and do some resistance measurements, because it's a pretty quick and easy thing to do. So in this chart here, we've got all the tubes here and the 2 pins and what you should measure resistance wise. First 2 of the tuner tubes and the IF tube, so they kind of have these arranged going from the antenna input through the IF and to the sound output tube, the 6AQ5. So they must have done that intentionally, ordered these tubes or numbered them that way. And then it goes down through, and the final one is the picture tube. So I never really thought about that before, but that's kind of nifty. So they arrange it from the antenna to the picture tube in a logical order. So I can pretty much stop my resistance checks around here, because if we've got bad sound, I'm hoping one of these resistance measurements is off, which will help me narrow down the problem. Won't be surprised if we got another bad control somewhere, but we shall see. I've started taking some resistance measurements, and I thought I'd take a few moments to give you guys some tips on how to do this. So this is from Sam's Photo Fact. I made a photocopy of it so I can make marks on it and not ruin the original. What we've got here is a grid showing resistance values. Most of these are resistance values from the 2-pin to ground. Some of them, however, have a little symbol next to them, like a cross. And if you go down below here, it tells you what that means. For example, a cross means measured from output of M2, which is the second selenium rectifier. If you refer back to the schematic, that is the output of M2. So for most of these, you clip one end of your ohm meter to ground, which in this case is the chassis. For others, you do what they say, like clip it right here. The other end goes to the 2-pin. So for example, the very first box here of V1 pin 1, so it should be 1200 ohms. So if I take my clip and get it on the output of M2, is down in here. take my other end and go into the tube pin. Now normally I'm used to doing this from the bottom, in which case you read the tube pins going clockwise. But I'm doing it from the top side now because I can't very readily get inside the tuner. So pin 1 is right here. You can look that up in a tube manual if you're not sure how to read that. You know, how to know which tube pin is which. So I've got 1,391 ohms. They say it should be 1,200 ohms, but that's not too bad. That's, within 10%. So I'm not too concerned. And then I went on and started measuring some other values. Pin 2, I got 81K rather than 60K. Pin 3 should be infinite, I got that. Pin 4 and 5 I scratched out because those are the tube filaments. I got the tube out, and with the tube out, there's nothing to conduct from the tube filament back to the chassis, so I'm not getting any readings. Same thing will happen on the next tube, which is this guy, which I've also taken out. But I already know I have filament continuity. Tubes light up fine. No reason for me to do resistance measurements on the filament pins. Pin 6 also infinite. Pin 7 should be 1.8 meg. I got 3.3 meg. That was pretty far off. And then the next two are 0, 0. Now when you find one that's off, like that 3.3 meg, it's time to start digging. So if we go back to the schematic and look up that tube, it's this guy, it's the RF amp. It's the very first tube from the antenna inputs. This pin 7's a little tricky to trace out though, because it goes to a lot of stuff. That's this pin right here. And it goes down through this little coil here through the tuner switches. So I imagine it goes down through here and it goes over this way to this coil and around, but then there's a cap there. Capacitors block DC path. They don't factor into the resistance measurements. We could forget about any of this stuff over here. Follow it down through the switch, goes down through here, through a 22K resistor, over through this capacitor here, which is a feed-through cap. That takes a signal out of the tuner, like one of these guys up here. And then it goes over, and eventually over to here where we start getting some resistors. 470K, 120K, 1 meg, 3.3 meg. So I would start checking those resistors. I will continue on with the other tube, which is 6U8 here. And then after that the IF tubes, 1, 2, 3. And I'll keep going until I get to the 6AQ5, that's the audio output tube, then I'll stop and resume recording and let's see what we've got. If some of these are really, really far off, like say we have an infinite value when we should have something like 1,000 ohms and I'm getting infinite, or dead short when it should be a high value, that's where I'll go first. But right now, this is the first place I would start checking because that actually is tied into the AGC bus. Okay, I finished going through the first 8 tubes, and the only values that were really outrageously off were again that pin 7 on the RF tube, and then pin 1 in the first IF tube, and both of these pins are connected via some resistors to the AGC bus. So I'm going to check what those, all the resistors that are in that network on the AGC bus. Otherwise, 60K, I measured 88K, not too bad. In general, all these are high, a little bit high, but I'd say within 10%. So that's why I say nothing, nothing outrageous. But yeah, so we'll start digging in there. On the back side of the schematic, on the SAMs, they have a resistor locator, so I can jot down those AGC resistors and hunt around here and find them all one by one. So let's see that. Well, this is starting to get kind of aggravating. I went through and did a quick check on all the resistors in that AGC circuit, and they all tested fine within a few percent. However, I checked them in circuit. I did not lift out one end of the resistor. Then that's generally the first test. Well, this is starting to get a bit frustrating. I went through and checked all the likely. Well, this is starting to get a little bit frustrating. I went through and checked all the likely resistors, and they all checked fine. However, I checked them while they were still in circuit. Usually that's alright, because they're connected to, say, tubes, and when tubes aren't powered up, they don't conduct rather. Also, there's no component you can have connected up to a resistor that's going to increase its value. So, for example, this should be 470K, and when I measured it with the ohm meter, I got about 470K. Now, if it measured lower than that, I can't tell if it's good or bad unless I lift out one leg of the resistor, because if the resistor saying parallel with it, that'll bring its value down when I measure it. But if there's no way you can have a resistor connected up to another resistor, or a cap for that matter, unless the cap's charged up, but the set's been off for a while, so there's no charge. So if a resistor measures high, it's going to be because the resistor has drifted up high in value, not because of another component that it might be connected to in a set that's not powered up and has no charge stored up in it. Well, these all measured within a few percent, so I'm going to have to go back and start lifting out one end of each resistor. Just to double check this, I went to the other set that has the same chassis that works fine, 1.5 meg from pin 1 on V3 to ground. This set, 2.7 meg. I also popped the tuner out, because there was one resistor in here that's in that circuit. That's that 22K in here. It goes both to pin 7 on this tube and pin 1 eventually over on this tube. But those are the two pins that are measuring high in value. I also was suspicious of this tuner because when I took a closer look at it, I noticed that the cover on it was pretty mangled and some of the screws were missing. It also wasn't too hard to get out. Unsolder just a few wires and take a few screws out and it slides right off. Well, I checked the resistors inside and there's a 22K and it's pretty close to the right value. One I did find that was off though is this 10K, this big 2-watt resistor here. That's measuring almost 15K, so while I've got this open I'll go ahead and replace that. And I'll double check a few other resistors. There's some buried down in there. And then I'll spray it with some tuner cleaner and then pack that back up. But even with this out of the circuit completely, I'm still measuring 2.7 meg, so this didn't really seem to have much of an effect, at least on pin 1 of V3, which is over in here. So I'm suspecting it's one of these resistors over in here. So I'm going to heat up the solder cup and pull the end of them out one by one and check them more precisely. I replaced those out of spec resistors in the tuner and I flushed it out with some degreaser and I lubed up the bearing points so it's working nice and smooth now. I then went on the hunt for a bad resistor, and I think I got it right on the very first one I checked. First one I wanted to check was the highest valued one in the chain, which is 3.3 meg. This is a first. This is very, very deceiving. Check this out. So, the resistor goes from this point right here where I've got this alligator clip over into this solder cup down here, right down here. So I heated that cup up and pulled out one leg. So got the clip on one side of the resistor, probe on the other, nothing, infinite resistance. Just to be sure, I'll touch it to the other side, 0 ohms more or less. Back to the other side, nothing, dead open. However, when I was checking this in circuit, I was getting about 3.3 meg. And check this out. Still got this clip going to one leg, which is still attached to the circuit. Put the probe into the cup where the resistor used to be, and look what I get. About 3.8 meg. So, just so happens that this resistor is completely open, completely shot, but with it out of the circuit, if you measure where it goes, you get about 3.3 meg. If I had lifted that leg of the resistor out, I never would have figured that out. So obviously I'm going to clip this out, get a new 3.3 meg in there, and I want to power this up again. Alright, that's sound. Like I was saying before I started working on this set, after having just restored two of them, I was curious what curves this one might throw at me. Well, we've got one so far. Next up, I'll pop in a picture tube and see if we got any high voltage. I'm going to go with a little test CRT to start out with, and I have replaced temporarily that bad brightness control. I'll use a more appropriate control when they arrive in the mail. For now, let's see if we got some high voltage. I think I hear signs of life out of the flyback, but on the screen. Well, let's see if we have any high voltage with the probe. I hear buzzing, it makes me think that we do have high voltage. Take it off, takes it out of the circuit, turn it on, puts it in the circuit. So I know this meter's off a little bit, so I'm guessing that's about 15,000 volts actually. Which might even be a tad high. Let's see what this says we should have. Yeah, nominally 11 kilovolts, 9.5 to 12.5 is the range there. But it might be a little bit high because this CRT isn't showing anything. If it was conducting, probably drop that high voltage down a little bit. So, alright, well, I'll have to check the voltages on the CRT base and see if I can figure out we're getting anything. Notice sometimes when I turn sets off, there's a little glimmer of life. So it powers down. Let's see if that'll happen in this case. Yeah, there it is. Seen that happen a few times before. So I think we're real close. I turned off all the lights and maxed out the controls, and hey, a ghostly image appeared. Let's see if I tweak vertical and horizontal hold. Can I actually get an image? Oh, looks good vertical, more or less. Horizontal. Alright, incredibly faint and out of focus, but keep in mind this is not the correct CRT for this. This is one of those little test CRTs. So man, just that one 3.3 meg resistor. If it hadn't been for that, I had this set up to this point a lot quicker, that's for sure. Alright, well, it's about 3 in the morning right now, so I'm going to bed. But tomorrow, if I find the time, I will pop in the full-size CRT. Let's see how it works out.